Okay, Brandon, if you're watching this video in Italy right now, stop watching, because if I was in Italy, I would do no math. I would like go see something fun, and yeah, I would order lots of pizza and spaghetti, and then breadsticks. I'd go visit Paris, right? And Vienna. Vienna's in Paris, right? Or Vienna's in Italy, right? Naples? Is Naples in Italy? Go visit Naples. We hope you have a great time. We can't wait till you come back. Here we go. All right, so I just want to finish off these couple pieces right here. There's not much to it. A, B, and C. Now every time I look back and Brent is spinning his pencil, he's like laughing at me because he knows he can do it and I can't. Whatever. I'm not even going to do any work with this triangle. I know the answer right away. I know the answers. You notice anything interesting about this triangle? Why? Yeah, look at this, 105 degrees, you got the opposite side of 4. That's smaller than 20. Is that possible? No way. So I don't even have to do any work. So if you see that on the test, you just say that right away. Now my guess is that at least 50% of the people would say sine of 105 over 4 is equal to sine of b over 20. But just realize that's not the case. Okay. All right, we try another one. Is that reasonable? Yeah. So, go ahead and solve for it, okay? You'll be good to go. All right. Any concerns? All right, so let's do the law of cosines. Law of cosines. Many triangles are not right triangles, but rather oblique triangles. We are able to solve using the law of sines for most triangles. But what about triangles where we are given all three sides? What if you're given side, side, side? Can you find any of the angles? The answer is yes, but we don't have a formula for it right now. Because if you use the law of sines requires that you are given an angle and its opposite side. What if you're not given an opposite side? What do you do? So let's use what we know about right triangle trig to derive a way to solve some of these oblique triangles. A, B, C. We don't have a right triangle? We make a right triangle. What should I call that red line? H for height. Very good. All right, so I'm going to write a couple expressions here. First of all, if I have a right triangle and I'm working with sides, I've divided this piece up into two parts. So I can't talk about just this side or just this side. I got to talk about all of C. So let's break it up into two pieces now. We'll call this side X. What would the other one be? Or X minus C. What? No. C minus X. I'll try to make many mistakes today, so Preston has to use his cruddy eraser. Alright, so that's what we got. So now, what formula do you know that requires the use of three sides of a right triangle? Pythagorean Theorem. Let's do it. A squared or x squared plus h squared is equal to b squared. Any problems with that? You're right. I got a second one. I've got the quantity c minus x squared, and I've got h squared And that's equal to a squared. You okay with those? What do they both have in common? An h squared. Well, let's solve for the h squared so we can get rid of it. H squared is equal to b squared minus x squared. And c minus x quantity squared. Whoops, sorry. And h squared equals a squared minus c minus x quantity squared. Sorry, Preston. I really feel bad. Alright, they're both equal to h squared, so they're both equal to each other. That got rid of our h squared, didn't it? So now we got b minus x, or b squared minus x squared, is equal to a squared minus the quantity c minus x squared. So you guys know that when we're using these triangles, we don't like things other than a, b, and c. You know, we got to get rid of that x. Well, if you notice, we got a negative x squared over here, don't we? Well, look at what's going to happen here. When you take negative x times negative x, you get positive x squared. Then you distribute the negative and you get negative x squared. Oh, our negative x squareds are going to go away, aren't they? But we have a slight problem. When we do square this out, what's c squared? C squared. And then c times negative x and negative x times c will be negative 2cx. And then negative x times negative x gives you positive x squared. So when I distribute that negative through, I come out with this. B squared minus x squared equals a squared minus c squared. Then what? Plus 2cx minus x squared. So I didn't completely get rid of the x, did I? But what can I add to both sides? X squared. And when I do that, they go away. That's so nice. So I've done I've done a little bit of work here. Writing a couple things. I've almost got a formula that really uses those three sides. I'm very close here. Formula so far is b squared equals a squared minus c squared plus 2cx. I just want to get rid of that x. The x is right here. There it is. Which trig ratio involves that side x? Cosine, because the goal for today is to use the law of cosines, right? So let's write it. Cosine of what angle? Cosine of angle A is equal to the adjacent over the hypotenuse. What's the adjacent over the hypotenuse? X over b. And if we want to solve for x, we just simply multiply both sides by b. So we get b times the cosine of A is equal to x. I could take this and substitute it in for... Will I have any x anymore? No, I get this wonderful formula. B squared equals a squared minus c squared plus 2 times, I'll write the b from the cosine, times c times the cosine of A. Oh, it's great. Wait till you see it in action. Right now it's just sitting on the sidelines. Wait till we put it in the game. Now, I will tell you that generally speaking, people don't like to leave the formula like this. What they like to do is they like to move things over to the other side. So they like to have the a squared, and then they have b squared. They add the c squared, and they subtract the 2bc times the cosine of A. So we'll write down, there's a number of different ways you can write these formulas. We'll write down 3 of them. I'll show you where they are in your sheet and stuff like that. So let's just flip it over and write the way that they write it, okay? Law of cosines. Traditionally, the 3 ways it is written is as follows. C squared equals A squared plus B squared. What does that look like? Pythagorean Theorem. Minus 2 times AB times the cosine of C. You could also write it, instead of solving for side C, you could solve for side B. Now before we do that, look here, okay? You got A and B, and here you end up with A and B. And if you're solving for side C, it requires the use of angle C. So if we write it like this, B squared equals, what do you think I have? A squared plus C squared minus 2 times AC cosine of B. Very good. And you could write it like this. A squared is equal to B squared plus C squared minus, right. Now, I give you those. They're right here. Right on that sheet I gave to you. All 3 of them. You can also use these that solve for the angle if you want. I'm not going to ever use these. I'm going to use just these. I'm always... Yeah, we can do both. It's just the more traditional way, and I like that. So that's what I'm going to do. But don't write... I didn't think that people would fully get this, but they really got it first hour. And so it happened at the end of class. Somebody asked a question. I was like, well, here's why that works. And they're like, oh. And then 4th hour, about, I'd say 2/3 of them were like, oh, yeah, that's really neat how that works out. So don't write anything. Just watch this, and then we'll try our example. Remember, the formula was A squared plus B squared is equal to C squared, but we subtracted off this 2AB times the cosine of C. And I'll show you, kind of what's neat about that, all right? If you've got a triangle, say we've got 80 degrees, and this is, 8, and this is, 12, okay? And if you were to use the Pythagorean Theorem here, this isn't a right triangle, is it? But if you were to use the Pythagorean Theorem to come up with this side opposite the 80, watch what happens. The Pythagorean Theorem says you have a right triangle. So, the hypotenuse of a right triangle, is that longer or shorter than this opposite side? It's longer, isn't it? In fact, if you do it, you would do A squared plus B squared, and then because it's too long, you would subtract off that little bit. So that's minus that 2AB cosine of C. That's what the formula does. It subtracts that off, right? And it allows you to find that side. But here's where it gets really cool. Let's suppose that you had a different triangle. Let's say you had one that looked like this. And you were to use the Pythagorean Theorem. Well, now when you use the Pythagorean Theorem, the side that you get is that could be longer or shorter than the real side. This could be shorter. So watch what happens. Is 100 degrees in the first quadrant or the second quadrant? Second. And is cosine positive or negative in the second quadrant? It's negative. So when you take the cosine of that 100, that becomes negative. So instead of subtracting a number, you're adding that extra distance up. That's what it does. Isn't that cool? Emily's ready to throw a party. She's so excited about it. I think it's great that cosine's able to handle first quadrant, second quadrant, and understands the difference between obtuse and acute. It's great. So let's do an example. Let's put it to work. We've done a lot of solving for triangles lately, haven't we? The problem is that some of these triangles, I'm going to give you one solution, some of them give you two, some of them give you none. And we're always given different parts of the triangle. Will you tell me this? How is this triangle different than any other one that we've solved so far? It doesn't have an opposite side. You got the 26, but you don't got anything across from it. Well, that's no fun. So we use the law of cosines. You can see your decision tree says if you're given side, angle, side, which this is, as you can see, you're given a side, and the angle included between it, which is why you have your side, angle, side. It says there's one solution. Use the law of cosines. So that's what we're going to set up. And it's really no big deal. It looks bad, but it's really not. And which side are we going to be solving for, do you think? You're going to solve for A, B, or C. We're solving for A. That way we have an angle on its opposite side. So let's solve for that side A. So I'm going to use this formula. A squared is equal to B squared minus plus C squared minus 2BC times the cosine of A. That's the formula I want to use. And we can just type in our calculator just like that. A squared equals, B is 12, so we have 12 squared. C is 15, so we have 15 squared. Minus 2 times 12 times 15 times the cosine of 26. Grab your calculator. I've heard 3 or 4 people now that when they were doing their law of sines assignment, they weren't working in degrees, they were working in radians. They were ready to throw their calculator, and then they figured out what was going wrong. Make sure that you're working in degrees right now because, again, we have a triangle, and it says degrees. So I'm going to type it all in, 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. And you just type it all in, it gives you 45.43. Is that your answer? No, that's A squared. So what do you got to do? Square root it. Root the answer. 6.74. Does that make sense that you get a side smaller than the other two? Hey, you got a 26-degree angle. Sure looks like it might be reasonable. Okay. Okay, last part then. What do you think we're going to do to find, we got to find angle B or C. What do you think we're going to use? Law of sines. But hold on. There's method or madness. If there's an obtuse angle, which one would it be? Would it be angle B or would it be angle C? Why C? Because it has the longest side. Can there be more than one obtuse angle in a triangle? No, if you had like a 98-degree angle and a 100-degree angle, those two would make 198 degrees alone. That's just not possible. So there's only one obtuse angle. Sine doesn't know the difference between obtuse angles and acute angles. It has no idea. For example, if you took the sine of 120 and then you also took the sine of 60, what do you notice about those sine values? They're the same. So when you would inverse 0.866, do you think your calculator gives you the 60 or does it give you the 120? It gives you the 60. It has no idea if it should be 60 or 120. Sine doesn't know the difference. It has no idea. So therefore, we want to make sure that we solve for the acute angle first. If C is possibly obtuse, then B has to be acute. That's why the directions say, when you use the law of sines to find one of the missing angles, start with the angle opposite the shorter of the two sides. So all that means is you look here at your problem. Well, that's calculus. You look here at your problem. B is opposite 12, C is opposite 15. So I'm going to work with the one opposite the shorter side. Okay? That's where I'm going to start. And the directions say that, as I've laid out for you. So we set it up. Sine of what? 26 divided by? Yeah, we don't know what it, or yeah, we got it. 6.74 equals sine of beta, sure we'll call B, divided by 12. Remember, there's no way that could be obtuse. Because if there is an obtuse one, it's angle C. But type it in, 12 times the sine of 26 divided by 6.74. Is that my answer? No. What do I have to do? Sine inverse, why? Because I'm solving for an angle. Yep. Second sine inverse of your answer, 51.3. How do you find angle C? Just subtract the 2 from 180. So 180 minus 51.3 minus 26. Well, so I'll just add 30, I guess. 102.7. Like I said, sine of 102.7. Look at the number you get. You get 0.9755. If we would have inversed that, your calculator doesn't come up with the 102.7. It comes up with the 77.3. That's what we would have gotten, and that's not the correct answer. That's not the correct answer. So, like I said, you got to start with the shorter side when you do that. Yes. Okay, I'm done. We're going to do this one tomorrow. What's different about this one? It's all sides. So get your practice with what we're doing right now. I've got, let's see, where did that assignment go? Nope. There it is. 6.5, page 118. For 1 through 4 in problem 7, all you're looking for is an opposite side. That's it. Okay? You're not asked to do anything else. But for 11 and 12, you have to solve the entire triangle. Is it possible to come up with 2 solutions for side angle side? No. Do you remember when you were working in geometry and you were given side angle side? Was that a congruence theorem that worked? It was. So that's why you just have the one triangle. One triangle. Actually, Britton, if you are watching the video, Sydney's made a list of different souvenir items she's hoping you could bring home. So we'll try to put that together in our next video. I don't have time for it right now, but she said it shouldn't run you any more, a couple $100. So have fun. We'll see you later.